We have a definite integral. It's problem number 2 from section 5.4 in the Thomas's calculus book, and this is a pretty straightforward and definite integral. If I said indefinite, I mean definite. So basically we're just going to integrate and then evaluate. So using the fundamental theorem of calculus, that's the section 5.4, and so we get the integral of 5 with respect to x is 5x minus, we go up, this is 1/2, sorry, 1/2 times x up by a power of 1 is 2 over the new power, and then we're going to evaluate it from -3 to 4, and I'll clean that up a little bit, although I don't know it really needs to be, but anyway, you have 5x minus 1/2 times 1/2 is 1/4 x squared, and then we evaluate it from -3 to 4. So now we're going to evaluate it. So we say fundamental theorem of calculus says we evaluate the integral at the upper limit and subtract the value we get when we evaluate it at the lower limit. So we're going to say 5 times 4 minus 1/4 times 4 squared minus 5 times -3 minus 1/4 times -3 squared. And notice I probably even should have used some brackets, but notice how I was sure to put parentheses around this because I am going to have to distribute this -1 when it comes time to evaluate. And I'm going to do something too, and I'll show you in a minute. But anyway, 5 times 4 is 20. -1/4 times 4 squared is 16. And -1/4 times 16 is 16/4, which is actually -4. But I'm going to show you something that I kind of like to do. Because I know I'm going to have 9/4 over here, I go ahead and leave this with this common denominator. That way it's a little easier. I'm going to have to get a common denominator anyway, so I might as well leave that. So I always leave my denominators there. I don't simplify unless I can already foresee that I'm not going to have a problem. So then that's going to be minus, and it'll become clear what I'm talking about in a second. Minus parentheses 5 times -3 is -15. Minus 1/4 times -3 squared. -3 squared is +9 times -1/4 is 9/4. So now if I distribute that -1, I get -20 minus 16/4. Negative times a negative is a positive 15. Negative times a negative is a positive 9/4. So I end up getting 20 plus 15 is 35. -16/4 plus 9/4 is -7/4. I still need a common denominator, but at least I didn't have to do it for that part. I guess, I don't know, that's debatable, but sometimes it helps to actually leave the denominator there. In this one, it probably really doesn't matter. Either way, I'm trying to think, if I had a -4 here, that would be 31, and 31 times 4, just as easy or as hard to multiply 4 times 35. So getting a common denominator for the 35, I get a 4 times 35 is 0. Add the 2 to 12 is 140/4 minus 7/4, and then that's going to equal 133/4, and that won't reduce. So that's the value of the integral, the definite integral.